I have to close everything first, then we start off. Okay, right. Now, we know that there are many normal distribution. Each normal distribution has its own mean and variance, or mean and standard deviation. So all the normal distribution, they are all different. So if you want to find the area under the graph, you have to do differentiation, you have to do integration. Integrate from here to here, find the area. Then another normal distribution, another mean, and another standard deviation. You have to do another integration again to find the area under the graph. But it is not necessary. It is not necessary. They have given us the calculator and the table, right? The calculator and the table. The calculator is like this. The table is one cannot move already. The table is like this, right? The table is like this one. So the table is like this. The calculator is like this. So they have given us the table and the calculator to find the probability. We don't need to use the integration to find the area under the graph. But then the table and the calculator, they only give us one normal distribution. That normal distribution is the standard normal distribution, right? Now, our normal distribution is something like this. The mean is 12. The variance just now, how much is the standard deviation? I cannot remember. So we have one mean and one standard deviation. But this normal distribution, which has the mean equals to the mu and the variance equals to the sigma square. This is the normal distribution that we encounter every day. Now, this normal distribution, we can actually convert it to another normal distribution. That normal distribution is the standard normal distribution. This standard normal distribution has mean 0, variance 1. If the variance is 1, the standard deviation is also 1, because square root of 1 is 1. Okay, so this normal distribution, we can actually convert it to a standard normal distribution. The process of converting this normal distribution to standard normal distribution is called standardization. Some people use the word normalization, right? But they say normalization is not accurate. The correct word should be standardization. So the process of converting one normal distribution to a standard normal distribution, you see the word standard here. This one is just normal distribution. So if you want to convert it to a standard normal distribution, it is called standardization. How to do this standardization? We can use this formula to do the standardization, right? So this formula, Z equals to x minus mu over sigma. This one is the small letter sigma. Okay, so this is how we convert the x into Z. Okay, so x is our continuous random variable. Then we convert it to Z, the standard normal distribution, right? So we continue. Standardization is the process of converting a normal distribution to standard normal distribution using the formula. So we use this formula to convert an ordinary normal distribution to a standard normal distribution. Then you may ask me, hey, why are so difficult? I must convert to a standard normal distribution. Why? Why must we convert it to a standard normal distribution? The reason is because the table, the calculator, the values are all set using standard normal distribution. Our calculator and our table, given in the exam, the table given in the exam is set using the normal distribution. So if you want to find probability, you have to convert it to standard normal distribution to find the probability. Then That is the probability of our normal distribution. Okay, so what is the reason we want to use standard normal distribution? To find the probability. To find the probability. Using this one can find or not very difficult. You have to integrate each mu and sigma, you have to integrate differently. So no need. So we use table, right? So that is the reason why. So the way that you want to convert from a normal distribution to a standard normal distribution is this formula. Z equals to x minus mu over sigma. We are going to look at how to use this formula. Okay, so why convert? Because it is to enable us to find the probability of x distribution from a table or a scientific calculator calibrated in Z. Our scientific calculator is calibrated in Z. So we have to convert to Z to find the probability. Any questions so far?
No, teacher.
No, then you can read question number 1, how to convert. How to convert.
A continuous random variable x is normally distributed with mean mu equal to 24 and a standard deviation equal to 6. Find the z-score if x equal to 19.5.
Okay, what they mean here is like this, Let's say if there is a score here, there's the x, okay? There's an x here, or somewhere, oh, here, the x, okay? So there's an x here, and this x is 19.5. The x here is 19.5. But on the z-axis, what is that number here? It's not 19.5. What is this number? The number here is 19.5. What is the number when it's converted into z? That is what they want us to find. So we are going to use the calculator, the formula to find. We are going to use this formula. Z equal to x minus mu divided by sigma. So our score Z, this Z is called the Z score. The Z score equal to, what is the value of X? 19.5. Minus mu. What's the value of mu? Or mu is 24 given here. Then sigma. What is the value of sigma? You see, oh, sigma is 6. So we substitute all the numbers into this formula and we get the answer negative 0.75. Now this number negative 0.75 you can find from the calculator or from the table, right? You can find from the calculator or table. Okay, so this is how we convert. Substitute the numbers into the formula. Can you read question number 2?
X is a continuous random variable that is normally distributed such that x n 500, 169. Find the value of x if the z-score is 1.35.
Oh, so we still use the formula berani kerana benar. But this time the z is given, the x is not given. So we quote the formula. The formula is z equal to x minus mu over sigma. What is the number z here? Is given?
1.35.
Correct. What is the mu here given?
Mu is 500.
500. What is the sigma here?
Wait,
It's the square root of this number. It's not this number. It's not 169. 169 is the
13.
square. 13, correct. So we substitute inside 1.35, 500, then this one is 13, right? 13. So solve for x. X is 1517.55. It means on the z-axis, the number is 1.35. On the x-axis, the number is 517.55. Okay, no? So this is the meaning of it, right? Okay. Now, next one. Read question number 3.
The diagram on the right shows a normal distribution graph for the mass of smartphones produced by an electronic factory. If the standard deviation is 0.05 kg, find the z-score when the smartphone chosen at random has mass of 0.14. The mask of a randomly chosen smartphone is if the Z score is negative 0.12.
Okay, right. So another question, right? The question is what? The diagram shows a normal distribution. Now this is the x, not the z. Z is always zero. The center line is zero. That is z. But this one is the x. Okay, the center line is 0.15. So they say standard deviation is 0.05. So no need to square root lah. So this number you can use straight away. Find the Z score when a smartphone has mass 1.4. So this is the normal distribution, 0.15, 0.05 square. Because this one is standard deviation. If I want to write here, I have to write the variance, so 0.05 square, right? So this is the formula. Substitute the numbers inside the formula. So the numbers, they are x what 0.14, mu 0.15, sigma 0.05. So use your calculator. Answer is 0.02. Now the second part, they give you the z, ask you to find the x. So using the same formula, you substitute the number. The number given is negative 0.12. So you put here negative 0.12, mu 0.15, sigma 0.05. Solve the equation, you have x equal to 0.144, right? So this is how we're going to make use of the formula. The last one, can you read the last one, number 4?
A continuous random variable x is normally distributed and is symmetrical at x equal to 45. If x is standardized to have a standard normal distribution, it is found that x equal to 60 is standardized. It is found that x equal to 60 is standardized to z equal to 1.5. State the mean and standard deviation of this normal distribution.
Oh, this one is slightly different, right? They give you the value of x and they give you the value of z, right? So they ask you to find the mean and standard deviation. So the first one, they say is symmetrical about 45. So you know that the mu is 45, right? The first one, they say x is a normal distribution and is symmetrical about x equals to 45. So you know the mu is 45, right? So they say state the mean. This is the mean, mu 45. The next part, you have to use the formula. How to use the formula? The mu is, sorry, the z is 1.5. Z is 1.5. Put inside. X is 60. You put x equal to 60.